Hi guys, I want to just take a minute to discuss the formula sheet. There's things on here that you need and there's things on here that you don't need. The first one you see up here is the average. This is just taking the sum of the observations dividing by the total number of observations. You can get this on your calculator. You don't need it. The next things here, SX, SP, don't need it. But one thing you do need is I would pause right now to really highlight your formula sheet is you do need y hat is equal to b naught plus b sub 1 of x. What will happen in this circumstance is when you need it is you will first need b sub 1. b sub 1 is the slope. You will be given a situation where you are given the correlation, your r, right here, the standard deviation of y, the standard deviation of x, and then you'll be given the mean of x and the mean of y. And I have that in my topic 1 bivariate or part 2, maybe part 3, we'll see. But I do have that in one of my study guide videos. So make sure to check that out, and it's when I talk about bivariate data. So back to b sub 1. You'll be given your correlation coefficient and the standard deviation of y and the standard deviation of x. And you can use that to find the slope, b sub 1. You then take that, so go up the ladder here, and you have your b naught. You'll be given your y bar, the average of the y, and the x bar, the average of the x. And you've already found your b sub 1 down here. You plug it all in right here, and you get your b sub naught. Then you finally take your b sub 1 and your b sub naught, and you plug it into your regression equation right here. And again, please check out my YouTube videos so you can see an actual example of that happening. Right now, the goal is just to talk about the formula sheet. The next page on your form, so this descriptive statistics will be your first page. The next page will be the probability. This first probability, remember, is for the keyword or. If you say, what's the probability of driving a red car or a Ford Explorer? It's the probability of the red plus the probability of Ford Explorer minus the probability of both. Now, if the situation is mutually exclusive, meaning you can't do it at the same time. For example, what's the probability I drive a Ford Explorer or drive a Jeep? That's the probability I drive a Ford Explorer plus the probability I drive a Jeep. We don't subtract the both because it won't happen at the same time. Here is my given situation. It's conditional probability. The probability of A given B has happened. I always think of this as my denominator, my fraction bar here, this line. The probability of B goes in the denominator right here. And then say, what's the probability that both will happen at the same time? That goes in my numerator. You'll use this for things with fraction trees or two-way tables. Here's my formula for expected value. I take my expected value, and this is how I show my work. I've done lots of videos on this, so check my videos out. It's the sum of the observation, this xi, times the probability of that observation. And just keep adding it up. Observation times the probability of the observation. Dot, 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 and you can continue the pattern. Unfortunately, they don't give you the standard deviation, so you need to remember that the variance is your standard deviation squared. So when you're showing your work for the standard deviation of a probability distribution, an example like this would be number 5 from the 2002 exam that we just took in class. I take the standard deviation, I take the square root of the sum of the observation minus mu of x. What's mu of x? It's your expected value. Square it times the probability of that observation. Continue the pattern. Plus the next observation minus the expected value, squared times the probability of that observation. Now remember, all of this, E of x and the variance of x, or the standard deviation of x, you can get in your calculator by, now write this down if you don't remember, and it's just like number 5 on that 2002 exam. L1 is your observation. L2 is the probability of the observation. Hit one variable stats, L1, comma L2, or list L1, frequency L2. Below on the formula sheet, we have our binomial distribution. You can do this all in your calculator with a binom PDF or binom CDF. Okay? Now, you really only need to know this formula for a multiple choice, and you'll see this in the 2002 exam. So make sure you look at my 2002 exam explanations. Right here, this is the mean of a binomial distribution, and here's the standard deviation of a binomial distribution. One thing they don't have on here on the formula sheet that you need to have memorized: the mean of a geometric distribution is 1 over p. You don't really need this next stuff. This is on the next page of your formula sheet. Here, this page you will be using a lot. This is your z-score right here, your zoms or your toms. Your observation is always your statistic minus your mean. That's always your parameter, your p or your mu, divided by the standard deviation of the statistic. What's the standard deviation of the statistic? Remember what I've always taught you about your method. You ask, how many samples do I have? One sample, or 2? Then you ask yourself, am I dealing with a z or a t? Remember, ZAP and TAX. ZAP has the word, or has the letter P in it. It's for proportions. Here's my standard deviation for a 1 sample. Right here, sorry. TAX has the letter X in it, and I write it with a bar over it. So I'm dealing with means. Here it is for a 1 sample. This one right here is for a 2 sample for means. Am I dealing with a t or a z? If I'm dealing with a t, I'm using this standard deviation. You will never use this one right here, so cross that off if you have your own formula sheet when you're studying. Now, when you're doing an interval for proportions and it's a 2 sample, you use the top one. When you're doing a test, you use the bottom one. How am I going to remember that on the test? Think of it this way. I, T, in alphabetical order. Interval comes first. I, alphabetical. Test comes second. T. Below I have my chi-square statistic. I take my observed value minus my expected. What should have happened? Square it divided by my expected. Plus... ... continue the pattern. And then finally up here, my confidence interval. I have my statistic. That's going to be either my x bar, my p hat, or my p hat of 1 minus my p hat of 2, or my x bar of 1 minus my x bar of 2, and then finally my slope. Plus or minus my critical value, my t star or my z star, times the standard deviation of the statistic, whatever you have right there. And when I say right there, I mean right here. And then finally, we have our charts, our z charts for when we use ZAP, and you need that. My t chart, you're mainly going to use that t chart for that t star. So here's your confidence level down here. Just remember, these right here are your z stars if you're dealing with a proportion. And then your t stars are all right here with your degrees of freedom. Remember, your degrees of freedom for a 1 sample when you're dealing with a t interval is n minus 1. For a 2 sample, you get it from your calculator and you use your calculator there. And then finally, For linear regression, your degrees of freedom are n minus 2. Your chi-square chart we don't deal with a lot with. You don't need to know that too much, but I can do a separate little video on that if we need to. And I've now discussed the chart. Hopefully that helps just give you a good reminder of your resources for the test.